Hi, good afternoon, everybody. I'm Jordan Howaro, and I will present to you our, our Real Vision IoT system, which is actually a system that enhances equipment and team performances throughout real equipments. Là, il y est pas? Better. So I will first quickly introduce what is Real Vision at Real, and especially its product, Real Vision IIoT, and give you some feedbacks about one of the projects that is implemented on this platform, which is ITER project. So Real Vision started 3 years ago, around 2022. It started during COVID-19, and especially during flight regulations. So we had expectation to do some more digital businesses throughout the world, considering COVID. Starting this date, we started to develop many products, starting from the Real Vision helmet, which is an helmet that helps us to connect remotely to on-site field team, using engineers teams to help us to do some work site. We also have the IoT platform, and we are working on the generative AI and also drone inspection. Today, I will speak a bit more about the IoT platform that helps us connect our machines and have our knowledge gathered to display to the customers some dashboards. So using this platform, we have many leverage, like optimizing the production because we can access and analyze every kind of signal we can fetch from the machine. We also can improve quality because we have better feedbacks from what's happening on the machine. We can also anticipate maintenance by combining signals from the machine and also faults. And we can also develop skills when we have manual operations. We are able actually to know what happens on the machine and what went well and what did not went well. The principle is quite simple. We have a machine on the left. We have to connect a PC, which collects data usually on a PLC on the machines. This edge computer is able to send the data to a platform. It could be a cloud platform or an on-premise platform, depending on the customer requirements. And then when we have this data on the platform, we are able to transform it and then to make some dashboards available for the users. We can also connect some external data sources to complement this data with other sources like report or inspections and do some dashboard based on these inspection reports and this machine data. We have actually 3 levels of intelligence on this platform. The first one being the monitoring level, on which we have only to make the machine speak. So we get the machine data and we look for what it say actually. Then when we have this data of faults, of process data, what was the state of the machine at the specific time, we can do some analytics using our knowledge at Real to do some more advanced KPIs. And after some weeks or some months, we're able to do some predictive KPIs on this application using our knowledge and the machine data. So an example that we have actually on this platform is the ITER project. So Real supplied 2 cranes in this tokamak assembly. We have some other cranes too, but this is the 2 main cranes we supplied that are 70-50 tons. And we also have the service contracts for all the electric equipment on the tokamak assembly. For ITER, this is a critical machine because it is the one that will have to lift every critical parts of the tokamak. So we have to ensure availability and reliability. I will show you a quick video that we made with the customer about the application.
Réel conçoit, fabrique et maintient des équipements pour les domaines industriels les plus complexes. En 2022, nous avons lancé Real Vision, le service dédié aux solutions de l'industrie 4.0.
Le projet ITER consiste à réaliser une plateforme technique réacteur thermonucléaire et démontrer que cette énergie est sûre et fiable pour les générations futures. Pour mener à bien ce projet, on doit compter donc sur le maintien du planning et assurer toujours le maintien de la sûreté.
Concernant les 750 tonnes, ce sont des machines qui sont les plus grosses d'Europe. La fiabilité et la disponibilité de ces ponts est très importante pour la réussite du projet.
L'industrie 4.0 nous offre La capacité de dérisquer les risques les plus importants sur nos équipements majeurs, d'anticiper des pannes importantes et améliorer la performance de ces équipements.
Real Vision IIoT est notre plateforme de connexion des machines pour nous permettre d'exploiter les données de fonctionnement de ces mêmes machines. Les données sont collectées puis transformées pour construire des tableaux de bord et indicateurs qui nous permettent de mieux comprendre comment les machines fonctionnent et sont opérées.
Real Vision nous alerte sur des pannes sur lesquelles nous pouvons intervenir rapidement, mais ça nous sert aussi à analyser tout ce qui peut être petits signaux, de sorte à réaliser de la maintenance corrective avant une casse.
La solution proposée par Real répond à nos ambitions puisqu'elle a vraiment été coécrite et taillée sur mesure.
Dernièrement, on a retrouvé un défaut récurrent. En utilisant le 4.0, nous avons pu regarder quel était le tout premier défaut, le résoudre en cause source, de sorte à remettre les ponts en fonctionnement à 100%.
Ça nous a aussi permis de savoir quelles sont les zones de roulement fortes sur l'ensemble de la voie de roulement, ce qui permet aussi de venir cibler les actes de maintenance et de ne pas d'immobiliser les ponts roulants pour une révision générale. La prochaine étape avec Real Vision, pour moi, c'est de passer d'une maintenance préventive à une maintenance prédictive et pouvoir anticiper tout incident qui pourrait entacher la performance de nos équipements.
Real Vision IoT est l'un des produits de Real Vision, mais nous travaillons aussi sur d'autres outils tels que l'IA générative par exemple, ou l'intégration de machine learning dans nos dashboards pour tirer le meilleur des informations qu'on peut collecter des machines.
Okay, so you may have seen these dashboards on the video. So I took some screenshot of it some days ago, and we can see many information in it. So usually here we only have the machine data that we transform over time to build indicators. These indicators will allow us to optimize production, anticipate maintenance, improve quality, and develop skills. And we'll see why just in a second. For instance, this indicators is about the lifting cycle. So usually the PLC does not know about which lifting cycle it is on. He only knows about, well, the load it lifts. And we are able to know regarding the state of the machine, the load lifted, and the other data of the machine. We can know if it's starting a lifting cycle or if it's ended. And then we can count on this period some values and some data. So for instance here, we can see that many of these lifting on this waste hoist has been below the 100 tons, which is not usually what we want to operate with this kind of machine because this is a 750 tons crane, for instance. And these kind of indicators help us to know, without having to ask operators or to see physically what happens, that this crane is used for some low lift. We are also able to send notifications regarding some behavior on the machine. Here, for instance, we can know when there are some jogs on the machines. So when the operator manually presses multiple times in a short time a direction, we are able to monitor it and then after to send a mail or a WhatsApp notification or SMS or Teams, whatever channel we want to use. And when we have this event, we can see some other data that we have on this machine. So the PLC send this data every time, and we have to frame it and give it to a notification. For the maintenance part, we are able to see every fault that happens on the PLC and see the history of it. So we can see the timeline below, but we can also have the context of each fault. If we want to have more overall KPIs, we can see which are what are the faults that are the longest, that happens the most of the time, which are the ones that happen too much, and see ranked here on this Pareto diagram what are the faults we want to work on to anticipate maintenance. We can also see for every fault the context, so when this fault in blue occurred, what was the load, where the crane was, in which mode, etc. For the quality, one of the most critical lift from ITER perspective is the lift of the sector module, which is the highest one. And we have many load transfer during this operation because we have to take the piece from the horizontal side to the vertical one. And then we will have some load transfer. And during this tandem mode with the two cranes, we have to monitor closely in real time what happens on these hoists. And these kind of indicators help us to do so. And for the skills, I mentioned a bit earlier the jogs. So we can monitor all jogs that happens on this machine. So when the operator just press many times the button on one direction, and then we can see the context of these jogs. When he did it, we can also contact him and offer him some training to better operate the crane, and then we can have better maintainability of the crane too. So if you have any question, do not hesitate. Thank you for your time.
About predictive maintenance, what are the capability of the system to monitor such signals, to have indicators to predict maintenance corrections?
So for predictive maintenance, we have first to build a model which will be based on the data we have from the machine. Usually, we do not want to add more instruments on the machine, so we use the PLC data first. If for these predictive models, we need some more data, like accelerators or maybe vibration sensors, then we are able to add it to the machine, read the data to the edge computer we see before, and then try some models in terms of predictive maintenance to help us having some insight and KPIs about these issues.
Hello. I want to know where are stored of this data. If they are stored in locally or remote storage. Thank you.
So this really depends upon the customer. So when the customer agrees on making us store the data on the cloud, for instance, we can do this. If the customer wants us to store it locally, we can also do this. So it depends upon what the IT customer wants to do, actually. We're able to deploy it in a controlled environment. We're able to deploy it on the cloud environment too. So it really depends. But it's compatible. No more questions?
Thank you. I did not really catch what is the added value of your system, because coming from PLC in the system, you already have the data. So what is the added value in the IIoT? Because you already control your PLCs and all the data are in your system. So I don't really catch your point.
Okay, thank you for the question. So usually on the PLC, we don't have a big history on it, and we cannot have all the context transformation on it. So for instance, when we have a fault occurring at 10 a.m., we are not usually able to know what happened directly on the PLC some minutes before. And on our platform, we're able to do this automatically. So whenever we see a behavior that we want to monitor on the PLC, we're able to look at it in the data that we receive. And when it occurs, we just do some calculations and can display the trigger data. Okay, well, perfect. Thank you. Have a good day.